Hello, this is Dr. Amudapriya, Associate Professor Triply of Roshni College of Engineering and Technology, Palkulam. We are discussing about the power system analysis course. The lecture which we are dealing now is with the unsymmetrical fault analysis, the sequence networks and the sequence impedance. So earlier we have discussed about the symmetrical faults and its calculation, and in this lecture we will discuss about the unsymmetrical faults. So unsymmetrical faults may occur when one or two phases are being involved. The voltages and the currents becomes unbalanced and each phase is to be treated individually. They are not symmetrical in nature, right? So now the shunt type faults are nothing but the LG fault, LL fault and LLG fault. Single line to ground fault, line to line fault and double line to ground fault. The series type faults are nothing but the open conductor fault, where one or two conductors get open. When considering the fundamentals of symmetrical components, symmetrical components can be used to transform the three-phase unbalanced voltages and currents to balanced ones. The three-phase unbalanced phases can be resolved into three-phase sequence, normally positive, negative and zero sequence components. The positive sequence components, the three phasors are being equal in magnitude and they are equally displaced from one another by 120 degrees. And the phase sequence is the same as that of the original phasors. Let it be VA1, VB1 and VC1. While considering the negative sequence components, the three phasors with equal magnitudes are equally displaced from one another by 120 degree and the phase sequence is opposite to that of the original phasor. So let it be VA2, VB2 and VC2. Zero sequence components, they are equal in magnitude and they are displaced from one another by 0 degrees. There is no angular difference. So let it be VA0, VB0 and VC0. The relationship between the unbalanced vectors and the symmetrical components are such. VA, VB, VC is a additional or summation of the positive, negative and the zero sequence components of the respective phases. So here we will get the matrices VA, VB, VC is equal to 1, 1, 1, 1 A square A, 1 A square into VA0, VA1, VA2, where capital A, I mean the 3 cross 3 matrix is the component 1. Similarly, we can obtain for the currents also. While considering the sequence impedance, the impedances offered by the power system components, as we saw, they are positive, negative and the zero. In case of positive, the impedance component are flowing when the positive sequence currents are being considered. In negative sequence, only the negative sequence current flowing is alone considered. While considering the zero sequence form, when zero sequence currents are flowing, that impedance is alone being, that component is alone considered. So this is the case. So we can see for the positive sequence, we used to have the voltage VA along with the series reactance Z1 or impedance Z1. For the negative sequence network, only the impedance will be there, no voltage source. And regarding the zero sequence network, we do have two impedances. One is the zero sequence impedance and the other one is the neutral impedance. So next on drawing the equivalent circuits, we used to get this. This is the equivalent circuit of the transformer. Earlier it was for transmission line. This is transformer and this is for the load. So with this we can easily form the sequence networks. The unsymmetrical networks can be analyzed easily with the help of the sequence networks and the sequence impedances.